Yeah, it's a pleasure. Hello once more. It's not every day that we have the opportunity to roll out a new tool to the community, to the scientific community. And today is one of those days where we are happy to roll out the tool, even free for academic publishable research to the community, so that you can profit from something that we've been working on during 2.5 years roughly, in a collaboration that I'll briefly report about. So peptide analysis and design, PepSee, is made for you to facilitate your therapeutic peptide research. It all started with problems or questions like, given a set of peptides encoded as sequences, show me all those sequences that have a certain motive. Now, from our experience, the vast majority of people in peptide research use tools like Excel, and we'll have 2-3 polls during which we will actually ask you about your experiences and what you use, etc. But people use Excel, and then typically you are stuck at one point, because when we filter in Excel, typically we filter by column and not by line. So I have actually even seen customers who turn around the peptide display from top to bottom instead from left to right, as it would usually naturally be. So Excel seems to be pretty limited here and there, and the more you think about it, the more you realize that Excel cannot perform even this relatively simple task easily. That means not without quite some hassle around it. And there are similar questions that are actually addressed in peptide research. Questions like, could you pull me these amino acids that you find in a PDF file out there and just display them to me? Or align these sequences, something which we do very, very often in peptide research. Warn me whenever something occurs that I know of is prone for some processes that I do not want, aggregation, etc. Can you filter by general pattern occurrence so that I only see those peptides that I would like to see? Or something where more chemistry flows in, show me only those sequences that are similar to another one that I have. Something which gets more importance in perhaps larger organizations where there is a history of several projects. Something like, did we not have this sequence or something very similar in another project? So cross-project work is the key word here. All these tasks are extremely difficult to be accomplished with an Excel. The problems that we see overall here is that we have dirty data all the way. There are duplicates, typos, there is slang used. Often data is not up to date. This is especially true when you are not connected to certain databases in your corporation or organization. And manual housekeeping needs to be done as a consequence. So as soon as you try to copy and paste the sequence, the next errors without any checking are relatively near to you. Something like, can you update the solubility data automatically from a lab notebook so that you are sure that what is in your lab notebook is exactly the same thing as what is in the Excel view, in the view that you take a look at? And of course, all things chemistry. So the missing chemical awareness in there. Something which is extremely hard to do in Excel is, can you filter the positions 10 and 14 to 17 and show me only those residues that are hydrophobic in nature, but retain something at a certain other position, for example. Or cyclization support. All these are things that we really have quite severe problems with being time efficient when we use tools like Excel. Finally, also once you have worked on something, you would like to tell others about it. You would like to report to your boss, to your colleagues. You would like to write a paper about it, perhaps. And also here, we have found the reporting facilities, even though they are vast in Excel, sometimes simply inapt for peptide therapeutics. Yeah, and then there is the other point, the second part of our PepSee product development here, namely the design support when it comes to aid or help when you actually design the next peptide that isn't even in your Excel sheet. It was then when we realized, in collaboration with Zealand Pharma, that we have to do something about it. And I would like to very quickly, just in one slide here, summarize who is back behind this and who is backing this. The idea actually was much fostered and propelled by Thorsten Hoffmann, formerly CSO. Now he is Chief Operating Officer at Zealand Therapeutics in Berlin. Here's Jakob Tollborg, who worked as a project manager on this project, and a bunch of others from Zealand and from ourselves, who set up this project pretty rapidly and put this into an agile development context. So what we did is we had a full two-day interview phase at Zealand Pharma in Copenhagen on site. We consolidated this, prioritized that, and then we did every 2 months roughly, we did so-called story workshops where we reprioritized or reassessed or reconfirmed the priorities that we identified as being important use cases, important workflows that we wanted to support in PepSee over and over. Typically, it was only reaffirmations, but of course, there were ideas that popped up that made a lot of sense. So we coded them in, we delivered, even though not all functionality was there, we delivered very rapidly and then reiterated with the next most important thing. This way, actually, the first PepSee executable package was issued to the client, to Zealand Pharma, 6 months only after the contract signature. And there is nothing like a book of project specification or something like this. So it was a very rapid and very successful project that has now come to its end. Okay, let's walk through a workflow now with PepSee. I split this up in three parts, essentially a workflow of analysis design. And let's first look at how we get in sequences and data alongside and how we can actually work with that. So when you fire up PepSee, there will be a menu at the top of the software, and in that menu there will be a little icon, or an iconized menu, I should say, or something like this. And when you hover across those icons here, you will see that this is the load button. And with the load button, you can load sequences and data at the same time. And typically, since we have seen roughly 40% people using Excel, you will have something like an Excel sheet that you can directly import. I will show you how this actually works in a second. The other possibility that you may have is, once you have worked with PepSee on something different, you can, of course, also load in a so-called PepSee project file that will automatically be loaded and displayed. You can save PepSee files, of course, from within PepSee. Okay, so let's see. We have an XLSX sheet here, and this is actually the syntax that you will need. So there is a first column where the sequence needs to be, and you have other columns that you should give a name to. For example, some assays that you may have. So I have taken this from a paper here and typed in a bunch of sequences. And then within PepSee, you go to the load button, you click load, you navigate to your XLSX file, you simply click open, and then automatically everything will be imported here, will be displayed in PepSee, and you will see that the data and the sequences that we have just loaded in will be automatically displayed in colors. I'll say a few more things about this coloring, etc., and you are essentially already ready to go. Of course, several times you will have sequences that are relatively dissimilar but belong to the same mode of action, or that belong to the same target, etc., etc. And to actually recognize patterns in therapeutic peptide design, it's really of utmost importance to have them aligned. So if you did not pre-align them in some way, then you would want the tool to help you in aligning this, instead of actually going out of one tool, going to another tool, then getting back in and forth. And so simply you press on the align button and the respective sequence set will be aligned. Let me show you how this works. So in here, that's where we were before. and I explicitly added 2 fragments down here to the list of peptides where there is no assay data here, just to show you what happens when you click the Align button. So once we have these sequences here, we can navigate to the top and import, for example, additional sequences from, let's say, some other source to augment the set before we align. There is a removal of duplicates implemented, and here you see the supported formats. FASTA supported, PLN, simple text files, but also PDF is supported. And here I have a patent PDF file where we try to drag, here's a quick look, where we try to drag the peptide sequences that we find in there into PepSee automagically. And if we actually take this one and we click on open and we activated the duplicate checking before in the menu, then after 1.5 seconds or so, we see that we imported 163 without duplicates. We can click OK and we are ready to go. So if we now focus on the sequence information, we can see that a bunch of these sequences look pretty scrambled up. They are not really aligned, and we would like to actually align those. And the Align button is right here in the top right. And if we did not pre-select one sequence as our reference, then it will do a global alignment of all these sequences here. And now this looks much more tidied up. We can, in fact, select one reference sequence or one sequence as the reference sequence and use a certain display for this. So this is where we select our reference. And then if we click on this equal sign up here, then we will change the coloring to the so-called reference coloring, with which we see how much different the sequences are with respect to our reference. So there is a light blue or light cyan or light petrol, which says that this amino acid belongs to the same class of amino acids to which also the respective reference amino acid belongs. And when it's gray, then we are even not only similar by or within a class, but we also hop from class to another class, so we are entirely dissimilar. So I hope you can actually see the difference here between the darker petrol, the lighter petrol, and the gray sequences. So with this, you have a very speedy instrument at hand to rapidly obtain sequences from the literature, if they are not in graphical format, of course, because then we can't currently pull that out from PDF files. Quickly align them and relatively quickly also see what was worked on these sequences before. So I explained only briefly the coloring by amino acid class. I explained roughly the coloring with respect to a reference. And beyond simple coloring, there is also filtering. So not only can we color these sequences, but also we could say in sequence position number 10, I would only like to see certain amino acids of those classes here. By class, I refer to hydrophobic, polar, basic, acidic, and sometimes when there are atypical residues, etc., then there will be gray ones. These are the miscellaneous ones, or the ones that belong to the miscellaneous class. We can actually filter by chemistry, by motifs, that means by certain parts of the sequence, by position, by the number of mutations, and by the class itself. I'll show you how that actually works. So here we have what we had before. There are the 190 peptides that we had imported and read in. Here you see with a right click on the column header, we can filter with respect to the sequence positions. We can filter the names, and we usually automatically recognize whether there are also numbers in there. So you could say, show me anything that is below a certain threshold, but also by mutations. So for example, if we chose our reference and we would say, only show me those that are at max 10 mutations far away, we see that 125 drop out, and this filter can actually be toggled on and off very easily so that you can quickly go back to the full list of your amino acid list or your peptide list there. quickly change to the reference coloring system. We'll give you also a relatively quick overview on what has been done. So for example, in the right-hand part between 18 and 28, we can select to hide those because not a lot has been changed in these parts. Or we can say, for example, in column number 16, show me certain ones that are not really of that class that I already have in my reference, how much has been worked on that one. So for example, we can say at this position number 16, let's switch off all the green ones, all the polar amino acids, and check how much that list shrinks down. So we see in the status line at the very bottom, 64 survive. Now there's a lot of blue. What else has there been done? So we filter out the basic ones and we realize that essentially the hydrophobic residues have pretty much been undersampled here in this respective position number 16. Okay, this was sequences. Now let's talk a little bit about data. With respect to the data sources, I already mentioned that we can import them directly from our Excel spreadsheets, but certainly you can also manually type them in. So you essentially just double click in here and you can enter your respective value in there. You could also correct the one if that's not the one that should be there, for example. And the same holds true for new columns that you can simply add by clicking on that plus icon here, and there will be a column added with either numerical or textual values. This will be asked by a little dialog before this column is actually added, and then that was it. Of course, for Zealand, this work has essentially been taken entirely off their shoulders, because within Zealand, we have databases for the sequences and for the data. So once we connected the databases, the in-house databases within Zealand to PepSee, everything happened automatically, as I write here, because this is really a little bit of magic when everything is automatically up to date, always duplicate free, entirely consistent, etc., etc. So there is no hassle anymore with respect to data integrity here. Yeah, one word to our fellow commercial customers and listeners. Just please contact us if you would like to have PepSee connected to your corporate databases. There is a huge thanks due to Jan Holst Jansen from Biochem Fusion, who helped us a lot in integrating the databases on both sides, and who did a great job in propelling this database connection here within PepSee, towards PepSee and outside PepSee. Okay, then let's go to part number 2. Once we have analyzed our sequences alongside data, it's time to actually design new peptides. So how does PepSee as is today support the design of novel peptides here? What are the ingredients? Well, we would need a designer first. Having collaborated with a Danish company, of course, there is a Lego icon that we need to activate this designer. Once we click on the designer, we will add a new line at the very bottom of the table, as you will see in a second. We need an aligner. This is something that I already talked about before. And we, of course, would like to have visual support along the way. So here I made up an example with dummy amino acids. As you can see here, I wrote reference, compound, etc. to make you guys aware of how this relates back to references that I may have. And once we actually fire up our designer by clicking on the Lego icon, we can design a new sequence with respect to what we know from previous experiments, for example. So to this end, it's useful to highlight this as reference coloring. Click on the designer icon here. There is a new line, and you can simply type in or cut and paste from above your reference. One point, you arrive at a sequence where you don't know what to put, and then we can go to what we call the reference color, correlation caroling, where we can see how did an assay react with respect to this very position in that reference. So was it better than the reference, or was it worse than the reference? And we saw that we usually have green or yellow, that means improvement or more or less the same as before, which assures us that we should perhaps not change something too dramatically here. Once we have entered our new sequence here, we still have the possibility of doing a manual alignment, which is visually supported by the coloring, by the reference coloring on the fly. So you can see as I shift these around, the color of the residues change, and that alignment is evoked with the control key or the command key on the Macs, while you shift the sequences from left to right like pearls on a string. And with this, you can relatively quickly go forward, designing your next sequence that you would like to work on or to perhaps synthesize later on. I should mention at this point perhaps that once you have designed your new sequence and you have your connection to a database, of course things like validation and registration are relatively simple to be realized, as we've done this before with Jensen's help within Zealand. Of course, there is a lot of knowledge that you may have before you embark on your next peptide that you have. I blurred the sequences here for non-disclosure issues. But for example, you may be alerted, or you may want to be alerted once you enter something which is prone to be oxidized or deamidized, or which is prone to chemical degradation. And to actually make it as simple as possible for you, we have an ASCII file which lies besides the PepSee executable, where you can freely enter your own patterns. And you can see that actually the headline will be automatically taken as one of the points here in this highlight pattern dialog, with which you can also, or that you can use. There's another button right next to that, which not only lets you highlight these, but also filter according to those respective patterns here. So if you write chemical degradation and you put a bunch of sequence snippets under there from which you know that this is prone to chemical degradation, then this will automatically be displayed within PepSee for your convenience, and you could right away use this while you type and be alerted. The alerts pop up as the little circles around these respective residues here. And while I talk about these, I should mention that here on the right-hand side, you see a small letter as opposed to a capital letter, and there is kind of a D-shaped form around this letter, which tells you that this is a dexter, a D, a right-turning amino acid here actually. Okay. Having said this, it comes natural to realize that PepSee can learn over time from your own experiences. So this is an open door to actually have PepSee learn, for example, during a project, about things that you do not want to see, or that things that you do want to see, for example. I mean, this is not exclusive, but you could also focus on things that you would like to see. So this is on the fly, so it pops up while you type. Then, of course, cycles are a big issue. We implemented intelligent cyclization support. By intelligent, I mean that you can't just cycle anything everywhere, but it will automatically support you in having these bridges or cycles be created where they make sense. So let me show you an example how this works, because it also works with nested cycles. So if, for example, we have this sequence snippet here, and we go from a glutamate here to a K, and we say cyclization, then you see these little triangles, these pinkish triangles. And if you hover across these, you will see that this is highlighted. Similar for disulfide bridges, which are always yellow. So when you hover over a nested bridge, nested disulfide bridge, you see it in yellow, and the other cycles will get different colors so that you can distinguish them. And you can see that the cycle opens with a left triangle and it closes with a right triangle. This way we have a very minimalistic display, which does not disturb the tabular, very straight organization of the sequence view, and we don't have huge crossing lines above the respective amino acid entries that kind of, how should I say, that disorders our display of the sequences in PepSee. So telling and showing others, the reporting, of course, is the closing bracket for this process of analysis design. Once you're finished, you would like to get an overview. Driven by agile development, which is aggressively driven by priorities, we implemented the two most important use cases that Zealand let us know about. Namely, I would like to see from all the peptides that we've generated here and that we know of for this respective project, which ones are the most selective ones, or which are those that target two, or that we have good binding affinities or binding behavior for two peptides at the same time, which is very similar to the correlation issue. So do we see redundant data here? Whoops, I'm sorry. What did we do? We implemented two ways of display. What is special about this one, and actually this little thing here is like a link, so you can click on this column descriptor here and on this axis descriptor and on this axis descriptor to choose between the assays or the data that you would like to have displayed. But what is so special about this thing here is all these little dots here are clickable, and when you click here, then this peptide behind here will automatically be recognized and noted as a so-called favorite. And once you have selected certain favorites, typically with a few of those favorites here, you would want to have something like a spider plot or like a radar plot of certain properties here, so that you can relatively quickly see the difference between one or the other peptide that you should or should not continue with. Both these graphics facilities within PepSee have a little button on the top right side here, which makes the graphic go into the clipboard, so that you can just with a quick Control-V paste them into PowerPoint or Word or wherever you like. So once also this is done, often people would like to go back to the Excel world for whatever reason. I mean, the plethora of reasons why you would want to go back into Excel is endless, probably. So we integrated an Excel export, which works as follows. So you already see the little Excel button here at the top. So once we have all those sequences ready that we would like to export, we can use this little button up here for the report generation. PepSee sample will be renamed so that we don't override our input. PepSee work is done. We say save, and PepSee will ask us whether we would like to have a look at this generated report. Excel pops up, and then after a few seconds, it will display what we have seen before. So if you filter things out, they will not be in the report. There will be a so-called project overview tab. There is a data tab where we have the data separated. We have a compact peptide sequence here. And in case of database connections where we have longer names or abbreviations for longer sequence snippets, we can have the expanded peptide sequence. And this is really useful. So these are little miniaturized graphics of the peptide sequences that you can cut out, as ausschneiden in German means, and you can again just drop them with a Control-V into your document that you are preparing or your PowerPoint presentation that you may be working on. So this is the Excel export facility, which kind of closes the process or the demonstration of the workflow of peptides getting in, analyze, design new ones, do the reporting, and go back to the Excel world. So having finished this part, I would like to quickly highlight a few tool interplay ideas that we came up with during the project, actually. So once we take a look at PepSee, which is today an interactive analysis and design tool, which does this chemistry-aware data display and sequence coloring, filtering, etc. The obvious thing is a connection to the outside world and what is there. So especially the predictive methods, such as secondary structure predictions, conformation generation of at least parts of peptides, perhaps even work in 3D once we're in a lucky situation to have crystal structure information, or the Holy Grail using free energy approximations, or what kind of yields is being yelled for, that is use all the sequence and data combinations that you may have to do machine learning algorithms with it, and develop methods that may well be coined as artificial intelligence methods. So to give you a glimpse of what we did with this before, here's a little peek into the 3D world here. And a few years ago, in collaboration with Hamburg University and Roche in Basel in Switzerland, there was a statistics-driven notation or coloring system for rotatable bonds generated. So they looked at crystal structure data and did statistics on that, made the assumption that what has been observed frequently should be low energy, and what has been observed only rarely should be colored in red, such as here. And this was encoded into a traffic light system so that one could get a quick and rough overview of what is a likely torsion and what's not so likely a torsion. This is actually implemented in another tool that we have that you can also certainly download for testing right away from our download webpage. But what can you actually do with this? How is this helpful? So you may want to be up for peptide mimicking, or for replacing certain parts that you know of are unwanted, that you do not like, or to even do 3D pattern busting. So we used our recall algorithm that was also developed with Roche and Hamburg University, that is implemented in CISA. And I took something from a publication by Novo Nordisk and fed this into CISA here. And what we did here is we took out a snippet from this peptide, which is displayed here in the lower left in 2D, and we said, okay, let's assume that this is a part that we do not want. So we need to select this, and then we mine from a fragment library that was generated from small molecules, for example, but similarly you could use this with other peptides as a source, so that you only replace peptide parts by other peptidic parts. And then you can navigate through the list of solutions that is made in such a way that the part which has been inserted should not distort the rest of the molecule. So try to minimally invasively replace a part and come up, for example, with a heterocycle that leaves the other parts in silence, in place. And once you like this, you could export it and continue and do other work with this. In combination with this torsional coloring here, for example, you would automatically and quickly have an assessment of whether this torsion is likely to occur or not so likely to occur. So this just as a little peek into how this could be worked on in the future. So having mentioned that we roll out this tool freely without any cost to the academics for published research, you may ask, so how can I get started? Where is help? Do you have any introductions, etc., etc.? Well, we just a few days ago launched the PepSee website. That's the tool homepage, biosolvit.com/PepSee. You will find, when you scroll down a little bit, you will see a PDF of the first steps relatively down the list. And the little sample Excel file that I used in this demonstration, in this webinar, is also downloadable from down there at the very bottom. And we are working on a bunch of movies, on introductory movies that you get going quickly. And the typical location for movies that we do in this context would be our YouTube channel, which is youtube.com/biosolvit tutorials, all in one word, all in one crazy long word. Can I have it? Yes, you can have it. It's free for academic publishable research, and also commercial organizations talk to us. So we are not tied to any obligations with respect to this data visualization, etc. part from Zealand. So we are happy that they collaborate with us on getting the word out about this tool. But obviously, not all of the functionality that we put in here for Zealand is in that public version. Especially this refers to the database connections and the validation, registration mechanisms, etc., etc. But we'd certainly love to connect your own databases and the sequences to PepSee for you. Get in touch with us either through the tool homepage, or we have created a new pepsee@biosolveit.com email address for you, so that you can get in touch easily with respect to the wishes that you may have. And then mentioning this once again, since I see a bunch of academic institutions joining here from across the world, please come and visit our challenge website, join our scientific challenge to win a €1,000 travel grant to a conference of your choice. So with this, I'm at the end. We still have a quarter of an hour roughly for a Q&A session, and I'm keen on learning what's in your heads on this, what are your challenges, etc. Thanks very much for listening at this point.